Theorem 1.3, prove that root 2 is irrational number. So we have to prove that root 2 is irrational number. To prove root 2 as irrational number, first of all we have to assume that root 2 is irrational number. So this is by proof by contradiction, right? So we will prove it by proof by contradiction. Let us assume that root 2 is rational number. So when it is a rational number, definitely this will be in p by q form or some a by b form. And also let us assume that this root 2 will be equals to some a by b, where a and b are some co-prime numbers. That means they don't have any common factor except 1. So now bring this b to the left side. Now it becomes root 2 into b is equals to a. Now squaring on both the sides. Root 2 into b whole square is equals to a square. Root 2 square is 2 and b square is b square. So 2b square is equals to a square. Now send 2 to the right side. Now the equation becomes b square is equals to a square by 2. That means this a square is divisible with 2. A square by 2 means a square is divisible with 2. When a square is divisible with 2, a is divisible with 2. So a square is divisible by, here a square is divisible by 2. So a is, or a will be divisible by 2. So a is divisible by 2. So let's suppose when a is divided by 2, the quotient is, let a by 2 is equals to some c. C is some positive integer. So when a divided by 2, the quotient is c. Now send 2 to the right side. Now a is equals to 2c. Now squaring on both the sides again. A square is equals to 2c square. A square is equals to 2 square is 4 and c square is c square. Now we know that a square is equals to, so what is a square is equals to 2b square, right? Here a square is equals to 2b square. So therefore in place of a square write 2b square. So 2b square is equals to 4c square. Since a square is equals to 2b square. Now bring 4 to the left side. 2b square by 4 is equals to c square. Here 2 ones are 2 twos are. So b square by 2 is equals to c square. Otherwise we can write it as c square is equals to b square by 2. That means here b square is divisible by 2. So here b square is divisible by 2. Is divisible by so b will be divisible by 2. That means here 2 divides both a and b, right? When 2 divides both a and b are not co-prime numbers. So a and b are not co-primes. So this is contradiction to our assumption. We have assumed that a and b are co-prime numbers, but here a and b are not co-prime numbers. So our assumption is wrong. Therefore our assumption is wrong. We have assumed that root 2 is rational number and it is equals to a and b, a by b, where a and b are co-prime numbers, but a and b are not co-prime numbers, so therefore our assumption is wrong. So therefore root 2 is not rational number, root 2 is irrational. Next, see example 5. Prove that root 3 is irrational number. So the way we have proved that root 2 is irrational number, the same way we have to prove root 3 is irrational number. Let us assume that root 3 is rational number and it is equal to some a by b, where a and b are co-prime numbers. So bring root b to the left side. Root 3 into b is equals to a. Now squaring on both the sides. Root 3b whole square equals to a square. Now root 3 whole square is 3 and b square is b square. 3b square is equals to a square. Send 3 to the right side. B square is equals to a square by 3. That means here a square is divisible by 3. A square is divisible by 3. So when a square is divisible by 3, a is also divisible by 3. A will be divisible by 3. So let us assume that when a divided by 3, the quotient is c. C is some positive integer. Send 3 to the right side. A is equals to 3c. Now squaring on both the sides. A square is equals to 3c whole square. A square is equals to 3 square is 9 c square. Now replace, what is the a value here? It is equals to 3b square, right? Where we did find it? Here. So a square is equals to 3b square. So in place of a square, write 3b square. Three b square is equals to 9c square. Since a square is equals to 3b square. Now bring 9 to the left side. 3b square by 9 is equals to c square. Let's cancel here. 3 ones are 3 threes are. So b square by 3 is equals to c square. Otherwise we can write c square is equals to b square by 3. That means again here b square is divisible by 3. When b square is divisible by 3, b will be divisible by 3. So b square is divisible by 3. So b will be divisible by 3. So here 3 divides both a and b, right? 3 divides both a and b. So a and b are not co-prime numbers. So this is contradiction to our assumption. We have assumed that root 3 is rational number and that will be equals to a by b, where a and b are co-prime numbers. So our assumption is wrong. Therefore our assumption is wrong. So we have assumed that root 3 is rational number, so therefore it is not rational number, so therefore it is root 3 is irrational number. Next, example 6, show that 5 minus root 3 is irrational number. So we have to prove that 5 minus root 3 is irrational number. So 5 minus root 3, right? Let us assume that let us assume that 5 minus root 3 is rational number, and it is equal to sum a by b. 5 minus root 3 is equal to sum a by b, because it is a rational number, right, where a and b are co-prime numbers. So send minus root 3 to the right side. 5 is equals to a by b plus root 3. Now bring a by b to the left side. 5 minus a by b is equals to root 3. Now multiply 5 can be times 5 by 1, and it multiply with b by b to make the denominators equal on the left side. Minus a by b is equals to root 3. 5 into b, 5b by b minus a by b is equals to root 3. Now add the numerators on the left side. 5b minus a whole by b is equals to root 3. Otherwise we can write it as root 3 is equals to 5b minus a by b. So root 3 is irrational number, 5b minus a by b is rational number. For whatever the value you take for a and b, we can consider any number for a and b, you always get 5b minus a by b is a rational number, and root 3 is already we have proved it is irrational number. So an irrational number should not be equals to rational number. Here root 3 is irrational and for any positive or negative integer, for any integer of a and b, 5b minus a b is rational number. So an irrational number should not be equals to a rational number. So therefore our assumption is wrong. So therefore 5 minus root 3 is irrational number. Next, example 7. Show that 3 root 2 is irrational number. 3 root 2. Let us assume that 3 root 2 is rational number and it is equal to sum a by b. So where a and b are co-prime numbers. So now bring 3 to the left side. If you bring 3 to the right side, sorry, we have to send 3 to the right side. So root 2 is equals to a by 3 into b, 3b. So here root 2 is irrational number. Already we have proved it. So root 2 is irrational number and a by 3b is rational number. For whatever the numbers you take for a and b except irrational number. So a by 3b is rational number and irrational number should not be equals to rational number, right? So this contradiction has arisen because of our wrong assumption. We have assumed that 3 root 2 is rational number. Because of that contradiction, we got an irrational number equal to a rational number. Therefore, our assumption is wrong. Therefore, 3 root 2 is irrational number. Next, exercise 1.2. First question. Prove that root 5 is irrational number. Let us assume that root 5 is rational number and it is equal to some p by q form or a by b form. Root 5 is equals to a by b, where a and b are co-prime numbers. So bring b to the left side. It becomes root 5 into b is equals to a, squaring on both the sides, root 5b whole square equals to a square. Now root 5 whole square is 5 and b square is b square. 5b square is equals to a square. Send 5 to the right side. B square is equals to a square by 5. That means here a square is divisible by 5. So here a square is divisible by 5. So when a square is divisible by 5, a will be divisible by 5. So let us assume that when a is divisible by 5, the quotient is c. C is some positive integer. So send 5 to the right side. A is equals to 5c. Now squaring on both the sides. A square is equals to 5c whole square. Now a square is a square. 5 square is 25 and c square is c square. So 25c square. Now replace a square with 5b square because a square is equals to 5b square here. So we have proved here a square is equals to 5b square. So in place of a square, write 5b square. Five b square is equals to 25c square. Since a square is equals to 5b square. Now bring 25 to the left side. 5b square by 25 is equals to c square. Let's cancel here. 5 ones are 5 5s are. So b square by 5 is equals to c square. Otherwise we can write it as c square is equals to b square by 5. That means here b square is divisible by 5, right? B square is divisible by 5. So b will be divisible by 5. That means here b divides both a and b. A is divisible by 5, b is divisible by 5. So b divides 5 divides both a and b. When 5 divides both a and b, so here a and b are not co-prime numbers. But we have assumed that a and b are co-prime numbers. But here we got a and b are not co-prime numbers because of our wrong assumption. We got this contradiction. We have assumed that root 5 is rational number and it is equal to some a by b, where a and b are co-prime numbers. So therefore our assumption is wrong. So therefore root 5 is irrational number, not rational number. Next, second question is prove that 3 plus 2 root 5 is irrational number. We have to prove 3 plus 2 root 5 is irrational number. Let us assume that Let us assume that 3 plus 2 root 5 is rational number and it is equal to sum a by b, where a and b are co-prime numbers. So send 3 to the right side. Now 2b is equals to 2 root 5 is equals to a by b minus 3. A by b minus 3 can be written as 3 by 1. To make the denominators equal, multiply 3 by 1 with b into b. Multiply and divide with 3. Now it will become a by b minus 3b by b. Now denominators are equal. Add the numerators. Now this will be equals to a minus 3b by b is equals to 2 root 5. Send 2 to the right side. Now it becomes root 5 is equals to a minus 3b by 2 into b 2b. So here root 5 is irrational number. Already we have proved it. A minus 3b by 2b is rational number. For whatever the values you take for a and b, whatever the numbers you take for a and b, except irrational numbers, you always get a minus 3b whole by 2b will be a rational number. So this will be our contradiction to our assumption. We have assumed that root 5, what is that? We have assumed that 3 plus 2 root 5 is rational number, but we got an irrational number equals to rational number. So here root 5 is irrational and a minus 3b by 2b is rational number. So an irrational number should not be equals to rational number. So therefore here our assumption is wrong. So our assumption is wrong. Therefore three plus 2 root 5 is not a rational number, it is a irrational number. Next question is third bit, prove that following are irrational numbers. So 1 by root 2 is irrational number. Let us prove 1 by root 2 is irrational number. Let us assume that one by root 2 is rational number and it is equal to sum a by b. Where a and b are co-primes. So send root to the right side and bring b to the left side. Now it becomes 1 into b is equals to a into root 2. Bring 2 to the left, a to the left side. 1 into b is b by a is equals to root 2. Otherwise we can write as root 2 is equals to b by a. That means root 2 is a rational number. We have already proved it. B by a is a rational number. So an irrational number should not be equals to rational number, right? This contradiction has arisen because of our wrong assumption. So here root 2 is irrational number and b by is rational number. An irrational number should not be equals to rational number, right? Root 2 should not be equals to b by a. So our assumption is wrong. So 1 by root 2 is not rational number, it is irrational number. Next question is, prove that 7 root 5 is irrational number. So we have to prove same way of proving. Let us assume that seven root 5 is rational number and it is equal to some a by b, where a and b are co-prime numbers. Send 7 to the right side. Now root 5 is equals to a by 7 into b, 7b. So here root 5 is irrational number, already we have proved it, and a by 7b is rational number. Root 5 is irrational number and a by 7b is rational number. So root 5 should not be equals to a by 7b. So this contradiction has arisen because of our wrong assumption. So our assumption is wrong. Therefore 7 root 5 is irrational number. Next question is, prove that 6 plus root 2 is irrational number. Same way of proving. Let us assume that 6 plus root 2 is rational number and it is equal to sum a by b, where a and b are co-prime numbers. Send 6 to the right side. Now root 2 is equals to a by b minus 6, a by b minus 6 can be written as 6 by 1, a by b minus 6 by 1, multiply and divide with b to make the denominators equal on the right side. A by b minus 6 into b, 6b by 6b by b is equals to root 2. Now denominators are equal on the right side, so a minus 6b by b is equals to root 2. So root 2 is irrational number and a minus 6b by b is rational number, and irrational number should not be equals to rational number because of our wrong assumption. This contradiction has arisen. So here root 2 is irrational number and a minus 6b by b is rational number, and irrational number should not equals to irrational number. Because of our wrong assumption, this contradiction has arisen. So our assumption is wrong. Therefore 6 plus root 2 is irrational number, not rational number.